Thank you everyone for attending today's webinar co-hosted by Fresno State and the University of Delaware. This webinar was developed to provide guidance on where the North American railway industry is headed, as most of the major Class 1 railroads have adopted the management and operations strategy of the late Hunter Harrison, commonly referred to as Precision Scheduled Railroading, or PSR. This webinar considers the needed changes in policies, business decisions, and type of freight hauled for railroads if they're going to compete with trucking competitors and be profitable into the future. Steve?
Thank you, John. Let me welcome everyone, and first of all say a big thank you to our two university sponsors, California State University at Fresno and University of Delaware, and the rail programs in those two respective institutions. And there's a number of people that have been involved, and if I start naming them, I'll forget someone, but I definitely want to thank Dr. Alan Zaremski at University of Delaware for jumping in, and his colleagues, and those as well at California State University. So this couldn't happen without the efforts of those good folks. So let me just do a little bit of housekeeping before we launch into the presentations, and I think you will agree that we have a stellar cast of railroad professionals to tell us about the topics that John described today. We will have, let's see, two presentations to start us off, and then a lunch break, a half-hour lunch break, and lunch is on your own. Sorry about that. Then we'll start up again at Eastern Time, 1 p.m., and that will run through till 5 p.m. again Eastern Time. We'll have, after the lunch break, two presentations and then a short break. It doesn't say so on the agenda, but that'll be necessary. Will be necessary. So we'll have maybe 5 or so 10-minute break, and then the final two presentations, and then questions and answers for the last half hour, taking us up to 5 o'clock again Eastern Time. All right, with that said, let me introduce our first presenter, John Green. I'll tell you briefly about John. Dr. Green is an assistant professor of civil and railroad engineering at California State University, Fresno, otherwise known as Fresno State. His research expertise is in the field of railways and transit. Prior to his current position with Fresno State, he was an experienced project manager with more than 23 years of experience in civil engineering, primarily in railroading, with his career starting at the Illinois Central Railroad and with the CN Railway, including projects with highways, traffic studies, parking facilities, and traffic signals as an engineering consultant. Dr. Green holds 4 degrees. He has a Bachelor's of Science degree in Civil Engineering from Northwestern, a Master's of Science in Civil Engineering from Purdue, a Master's of Business Administration degree from Millsaps College, and a Ph.D. in Civil Engineering from the University of Nevada, Las Vegas. He has been the designer, field engineer, assistant project manager, or project manager for projects in various fields of experience. He has authored 3 peer-reviewed publications and 11 other publications. Dr. Green has planned, led, and taught 17 3-day seminars on behalf of ARIMA and taught one of the Mineta National Transit Research Consortium. Dr. Green is a former president of the Illinois section of ASCE, and he is currently vice president of the Fresno branch of ASCE. Also, he is current vice chairperson of ARIMA Committee 24, that's Education and Training, and a member of ARIMA Committee 17, High-Speed Rail. And with that, John, would you lead our webinar?
Thank you, Steve, for the introduction. So today I'll be speaking about how passenger rail is affected in a precision scheduled railroading environment. As a disclaimer, some of the research that I will speak about today was previously presented as a paper at the ARIMA Annual Technical Conference earlier this year. When I get to that material, I will point it out. I will first present a bit of background information and go into the history of precision scheduled railroading. Next, I will define what exactly is precision scheduled railroading, or PSR, as it is abbreviated. Then, because Amtrak is the primary provider of intercity passenger rail services and sole provider currently of high-speed rail service in the United States, I will provide some facts and some statistics about Amtrak as a whole and also on a route-by-route basis. I will also talk a bit about Canada's Via Rail. After that, I will describe the data that was analyzed and discuss the results. And finally, I'll present some conclusions that I drew from the research. Since 1971, intercity passenger railway service in the United States has been provided almost entirely by Amtrak, including North America's one high-speed rail experience, Acela, which operates in the Northeast Corridor between Boston and Washington, D.C. Unlike passenger railways in most nations, Amtrak rents its tracks from freight railway owners, paying annually $142 million to these host railroads, who dispatch the trains that run on their tracks. Because who controls the dispatching of trains determines which trains have priorities over others on a line, the operating strategies of the host freight railroads have a significant impact on the on-time performance of Amtrak's passenger trains. For years, Amtrak officials have been dissatisfied with the excessive delays in its passenger railway service that's caused by the host railroads. So, in March of 2020, the Federal Railroad Administration met with stakeholders and proposed a new minimum performance standard for its host railroads of 80% on-time trains. Clearly, Amtrak and the freight railways disagree on how to best run passenger and freight trains on the same tracks in the shared railroading environment of the United States. Also, to give a complete picture of the North American passenger railway operations, similar to Amtrak, Via Rail operates its trains mostly on tracks owned by the Canadian National Railway and the Canadian Pacific Railway. However, with a new operating strategy that has been gradually adopted by most of the largest freight railways in the United States and Canada over the past several years, called Precision Scheduled Railways, or PSR, the potential exists for positive change. Well, in 1982, at its lowest point in market share of the U.S. freight transportation market, railroads only transported 20.2% of the nation's freight, while trucks transported 32.4%. Since this low point, academics and railroad managers have earnestly studied how freight railroads work with the goal of developing the most efficient railroad operations possible in order to take back market share from trucking. Several research projects have developed railroad network simulation models to test the effect of various operating strategies on rail freight travel time reliability. The research concluded that precision execution of railroad shipments is a necessary condition for achieving service reliability. And carriers have a financial incentive to figure out how to schedule sufficient capacity to handle demand peaking. The work then concluded that railroads must improve reliability, particularly on single railcar shipments, if they hope to remain competitive with trucks in the future. The natural next question is therefore, what is the appropriate amount of railroad track, other railway infrastructure, and railway equipment to provide that sufficient capacity? Well, one definition of railway capacity is the maximum number of trains that would be able to operate on a given railway infrastructure during a specific time interval, subject to the railway operating plan. Capacity analyses are key to efficient train operations and have been calculated since the inception of the railway industry. The goal of a capacity analysis is to determine the maximum number of trains that can safely operate on a railway's tracks and yards over a certain predefined length of time, given the operating conditions of that railroad. In previous research, it has been demonstrated that railway capacity is not constant, but rather it depends on how the railway infrastructure is utilized. For example, the infrastructure parameters, the signaling system's block section lengths, whether a section of the route has single or double tracks, and the condition of the ties, rails, and ballast of the track structure all have major effects on maximum train speeds allowed, and therefore the number and size of trains run daily. Traffic parameters, such as the mix of trains running on a line, the percentage of trains that run according to regular timetables, and the prioritization and the total numbers of train priority classes affect capacity in a significant manner. Additionally, operating parameters such as train stop time, time spent in yards and terminals, and the reliability of service plans affect a railway line's capacity. The track and yard infrastructure and the railway signaling system are both somewhat straightforward quantities to determine, but the railway equipment utilization can be more difficult to assess. In an article by William Vantuono, it has been pointed out that equipment utilization has many facets and covers everything from railcar design to the scheduling of trains, but train scheduling is the most important part. The modern era of railroad scheduling started in the mid-1970s when the Association of American Railroads, or AAR, the Federal Railroad Administration, or FRA, and the Massachusetts Institute of Technology, MIT, worked together to create an operations service planning computer model that would focus on service quality and would make freight railroad operations more efficient. The data inputs for the model were origin-destination traffic volumes, throughput numbers for rail yards, train schedules, and unit costs. The outputs of the computer model were predictions of shipment origin-destination trip times and transportation costs for a particular operating plan. Several railroads took a strong interest in the project and its lessons learned, including the BNSF, the Southern Pacific Railroad, and the Illinois Central Railroad, where Hunter Harrison first became Chief Executive Officer. Railroads have long desired to improve the reliability of delivery dates and times for their customer shipments. Railway operations managers worked on developing sorting concepts for rail yards that would allow time-definite service with a guaranteed delivery date and time. By changing the way in which rail cars were assigned to outgoing trains from first come, first serve to ensuring connections of particular cars to specific trains, it was postulated that service reliability could be improved. What was needed was for a Class I major freight railroad to put the various ideas and concepts together and implement it as an operating strategy. In 1998, the Canadian National Railway was deep in debt and steadily losing market share of the freight transportation business to the trucking industry. In that year, the CN acquired the Illinois Central Railroad, and with it, the IC's CEO, E. Hunter Harrison, who had already implemented the strategy of point-to-point trip plans for individual rail cars that is now called precision scheduled railroading. After seeing the results of PSR at the Illinois Central, the CEO of the CN at the time, Paul Tellier, made Harrison the chief operating officer of the CN, and PSR was begun at the CN. PSR consists of 7 principles that allow a railroad to move the same amount of freight as done in the past with traditional methods, but with less people and equipment. It consists of 7 principles. 1, minimizing railcar dwell times in yards. 2, reducing railcar classifications. 3, using multiple traffic outlets. 4, running fewer specialized and more general purpose trains. 5, balancing train movements by direction. 6, minimizing locomotive power requirements. And 7, striving for more smoothed out, more steady work. The point of PSR is to streamline operations utilizing departure scheduling and point-to-point delivery methods in order to improve service to the customers. Before PSR, most railroads used a hub and spoke system in which rail cars enter a hub or terminal where they are placed on different trains and redirected to their destination. Railway operating strategy focused on moving long trains, maximizing capacity to yield the efficiency of labor and motive power, and railroads would operate both unit or single commodity trains and manifest trains, with unit trains being the preferred method. This approach did not always achieve the best outcomes for the railroad and its customers, because the strategy meant that if a train service headed to a specific destination city did not meet specific length requirements for its scheduled day of departure, it could be canceled. The result being that rail cars often sat for long periods of time in rail yards, thereby reducing the rail yard's capacities. The precision scheduled railroading concept, as Harrison developed, replaced the terminal-to-terminal shipment strategy with loading dock to loading dock strategy. By employing such an operating method and sticking to its schedules, a railroad eliminates much railcar switching within its yards and hauls freight from origin to destination more quickly, thereby reducing dwell time of equipment, which improves its asset utilization. Departure scheduling requires trains to leave on time, regardless of whether a customer's rail cars are ready to depart with their scheduled train or not. The combination of the departure scheduling and point-to-point delivery is intended to allow railroads to maximize running time at lower operating costs. How railroads using PSR strategies lower their operating costs is through the elimination of jobs thought not to be needed and through the sale of extra locomotives and rail cars, as fewer trains are run than previously done by the railroad. Additionally, most of the major railroads running PSR have expanded upon its cost-cutting efficiencies by eliminating many of their less profitable rail lines. In the previous ARIMA paper, I considered that there are two potentially positive effects of PSR operating strategy on the performance of intercity passenger rail train services. The first is that with PSR bringing more scheduled discipline to the host railroad's operations, intercity passenger rail service trains should have better, more reliable access to the host freight railroad's tracks when scheduled. Also, as the host railroad runs fewer, longer general service trains, delays are lessened on the railroad's tracks overall. Therefore, due to the positive effects of PSR, it can be postulated that intercity passenger rail trains could experience better on-time performance. Conversely, there are potentially three negative effects of PSR on intercity passenger railway service. The first is that PSR creates much longer trains than what was previously the normal length of what was considered long freight trains previously. Many freight railroad sidings were built to handle 1 mile long trains, but PSR means in effect that 3 mile long trains are common today. These trains cannot fit in most sidings, so this may mean that the passenger trains need to wait in sidings a greater percent of the time, because the up to 3 mile long freight trains cannot. The second potentially negative aspect of PSR is that due to having fewer employees and fewer repair facilities, any freight train mechanical failure may mean key tracks are blocked for longer periods of time, resulting in passenger trains waiting longer. The third way that PSR could potentially negatively affect intercity passenger railway service is that with PSR operating strategies, railroads try to do more with less, including less trackage. While freight trains may have been running spread out across somewhat parallel routes in the past, with PSR today, better asset utilization often means more densely packed main lines, often main lines where intercity passenger trains are operated. As demonstrated in previous research, whether a section of railroad has single or double tracks has a major impact on its capacity. When a railroad downsizes a main line track from a double track to a single track with sidings, its capacity is not reduced by half, but actually its capacity is reduced by roughly 75%. Whether PSR freight railroad operating strategies have a positive effect, negative effect, or no significant effect on intercity passenger and high-speed rail train on-time performance can be demonstrated from the performance data of the passenger trains. As I stated earlier, Amtrak is the nation's intercity passenger railway service and its current high-speed rail operator. Amtrak operates a national rail network of more than 21,400 route miles, serving more than 500 destinations in 46 states, the District of Columbia, and 3 Canadian provinces. Amtrak serves the 526 stations in the United States and Canada. In addition, there are 59 stations in the United States where Amtrak owns one or more station components, for example, station structure, platforms, or parking facilities, etc., but does not serve the station. Amtrak owns 18 tunnels consisting of 24 miles of track, and Amtrak owns 1,414 bridges. The Acela Express, Amtrak's high-speed rail service, travels on the Northeast Corridor between Washington, D.C. and Boston, Massachusetts, at a maximum speed of 150 miles an hour in that segment between Boston and New Haven, Connecticut. Its top speed between New York City and Washington, D.C. is 135 miles an hour. Amtrak is the only railroad in North America to maintain right-of-way for service at speeds more than 125 miles an hour. Amtrak engineering forces maintain more than 350 route miles of track for more than 100 mile an hour service, including the Michigan line between Porter, Indiana and Kalamazoo, Michigan. As stated earlier, Amtrak contracts with other railroads for the use of their tracks and facilities, with the host railroads in charge of scheduling and dispatching of trains on their tracks. Approximately 72% of Amtrak's train miles traveled are on hosts or other railroads' tracks, with the 5 largest host railroads by Amtrak train miles being the following: the BNSF at 6.9 million train miles, the Union Pacific at 6.2 million train miles, CSX at 5.0 million train miles, the Norfolk Southern at 2.3 million train miles, and the CN Railway at 1.4 million train miles. Amtrak's Canadian counterpart, Via Rail, runs more than 500 trains every week in 8 Canadian provinces. This covers 7,800 miles of track, 97% of which is owned and maintained by other railway companies, primarily the CN Railway. Via Rail carried approximately 4.39 million passengers in 2017, with the majority riding in the routes that connect Quebec City to Windsor, Canada, which is near Detroit. Well, to determine the effects of precision scheduled railroading on Amtrak service, you need to understand the host railroads and consider both the total minutes delay that the host freight railroads cause Amtrak to suffer, as we consider the percentage of Amtrak trains that are on time viewed over time. Fresno State has been researching the effects of PSR on passenger rail operations and presented on some of the effects on Amtrak at the 2020 ARIMA Annual Conference, as stated earlier. Further research has been done, including researching into the effects on Via Rail in Canada. Well, PSR gradually accepted by the major freight railroads, so knowing the year when PSR was first implemented at a railroad helps with the understanding of any significant changes to the performance of passenger service over time. Amtrak evaluates host performance based on host responsible delay minutes per 10,000 train miles, which is the measure of delay caused to Amtrak trains. This measurement is normalized for the number of miles traveled by each train so that different routes and hosts are compared. Then Amtrak assigns letter grades of A, B, C, D, or F for each host railroad. based on these delays and reports their grades on its website. For this research, Amtrak provided data for the years 2000 to 2019 concerning the performance of each of the 5 Class 1 freight railroads that host Amtrak passenger services. The key performance data listed on the next slide was provided by Amtrak, as I said. So here's the train delay by railroad data provided by Amtrak covering the period from 2000 to 2019. This data was placed into a graph on the next slide in order to show a comparison of the performances of each Class 1 host railroad over the time period of the year 2000 through 2019. You see a comparison of the railroads here. Note that BNSF has not instituted PSR, and also that the BNSF has the least number of minutes of Amtrak train delay per 10,000 train miles over the course of the past 20 years. The BNSF service level has remained relatively constant during the period studied, with a minimum delay rate of 614 minutes and a maximum rate of only 1,269 minutes. Also, the BNSF has had the most consistently good service with the smallest standard deviation for the rate of delay for the railroads, as seen in the table on the next slide. The Amtrak data allows a comparison of the host railroad's performance in the years before its implementation of PSR and its performance afterwards using PSR. The Canadian National Railway was the first railroad to adopt PSR in 1998, but data was not available for the years prior to 2000, so a comparison was not made as to the performance of the CN before and afterwards. The next railroad to institute PSR was the CP in 2012. Examining the data for the CP, prior to implementing PSR, the railroad had reached a maximum of 4,247 minutes of delay, but after PSR was implemented, the CP's minutes of delay rate has shrunk significantly, down to 1,209 minutes in 2019. The CSX implemented PSR in 2017, and it has experienced a significant decrease in minutes of delay, decreasing from a rate of 1,348 minutes in 2015 down to 989 in 2019, the best among the Class 1 freight railroads. The Norfolk Southern put PSR into effect in 2018, but its minute of delay rate has held steady since then without a significant increase or decrease. And finally, the Union Pacific instituted PSR also in 2018. While over the course of 20 years, the Union Pacific has had times of poor performance, delaying Amtrak trains, since 2010, UP's delay rate has held somewhat steady, being 1,160 minutes last year, which is the third best of the group of railroads. Another measure of the quality of intercity passenger railway service is on-time performance. The tables here, and also on the next slide, show each route of Amtrak that is hosted by one or more Class 1 freight railroads, the host railroad or railroads, and the percentage of trains on each route that are considered to have arrived within 15 minutes of their scheduled arrival times for the years 2002 to 2019. For the routes where the BNSF is the primary railroad by mileage, the Cascades, Empire Builder, Heartland Flyer, San Joaquin's, and Southwest Chief, the performance has held somewhat steady and currently averages 56.8% of trains on time. The CN is the sole host of the City of New Orleans. It is the secondary host on the Michigan Wolverine and the tertiary host of the Texas Eagle, which gives an average of 42.3% on-time trains. However bad the results, though, the CN has been operating with PSR since before the first year of data examined, so it is hard to draw conclusions as to whether or not PSR is the cause of the poor performance. The CP is the sole host for the Hiawatha and is the secondary host of the Empire Builder, averaging 69.5%. But for the Empire Builder, the CP operates less than 1/6 of its route miles. However, the performance of the Hiawatha averaged 93.5% on time prior to the CP's implementation of PSR in 2012 and has averaged 93.6% with PSR, suggesting that PSR has had no effect on passenger train service. CSX is the sole host of 8 routes: the Cardinal, the Carolinian, the Lakeshore Limited, Silver Star, Auto Train, Empire/New York, Palmetto, Silver Meteor, averaging out to 53.5% on-time percentage for 2019. CSX is the secondary host on the Capital Limited with an on-time performance of 31% in 2019. And on that route, it operates about 2/5 of the total route miles. Considering the 5 intermediate years prior to the year 2017, when CSX started using PSR concepts, and the data since then for 5 routes, the Palmetto, Silver Meteor, the Cardinal, the Carolinian, and the New York route to Albany, the rates did not significantly change. However, for 3 routes, Lakeshore Limited, Silver Star, and the Auto Train, there has been a small decrease in on-time performance. The Norfolk Southern is the primary or sole host railroad for 5 routes: the Michigan Wolverine, Capital Limited, Crescent, Pennsylvanian, and Piedmont. On all 5 routes, the NS has seen on-time performance significantly worsen since their start of PSR in 2018. Norfolk Southern is also the secondary host on 4 routes: the Cardinal, Carolinian, Lakeshore Limited, and the Silver Star, where each has held steady, with the exception being the Silver Star, of which the Norfolk Southern is a very small part. Lastly, the Union Pacific Railroad is the sole or primary host for 7 routes: the California Zephyr, the Coast Starlight, Pacific Surfliner, Sunset Limited, Texas Eagle, Capital Corridor, and the Missouri River Runner. The year of implementation of PSR at UP was 2018. Considering the range of the 5 years prior to 2018 through the present, on-time performance of every one of these routes has decreased significantly. Also, the UP is the secondary host for the Cascades and the San Joaquin's routes, and on both those routes, the on-time performance has also significantly decreased. Well, after reporting about the initial analysis of Amtrak and PSR at the ARIMA annual conference, Via Rail provided their on-time performance data for the years 2006 to 2019, as shown on the slide. The Montreal to Quebec route has held fairly steady in the time period covered, with only a small decrease in the on-time performance experienced in the last year, going from 82.1% to 76.7%. The Montreal to Ottawa route has held fairly steady with a 2019 on-time performance of 79.1%. The Toronto to Ottawa line is one of concern, with its on-time performance steadily decreasing over time from a wonderful 90% in 2016 going down to 64% in 2019. Montreal to Toronto has also depreciated significantly, going from an on-time rate of 85.5% in 2006 down to 56.8% in 2019. The Toronto to Kingston route has held fairly steady, and in 2019 was at 77.3%. The second worst deterioration of service was experienced by the Montreal to Ottawa to Toronto route, which dropped to 56% in 2015, then slightly recovered, and then continued dropping down to 42.7% in 2019. The Toronto to Windsor route has held steady over the years from 2006 and is around a rate of 72.8%. The Toronto to London route has decreased from 91.9% in 2006 to 70.7 in 2019. And lastly, the Toronto to Sarnia route was the worst change route, decreasing from 83.8% on-time performance in 2006, steadily worsening down to 47.7 in 2019. If we examine the ownership and therefore dispatching of the worst case lines, it is difficult to determine if PSR operating strategies have made a difference in Canada due to PSR being implemented on the Canadian National Railway prior to the year 2006, however, which was the first year of data available. In conclusion, the results are mixed, but when considering the measure of Amtrak host railroad minutes of delay per 10,000 train miles, they suggest that PSR may be able to improve a railroad's ability to reduce delays to the Amtrak trains that it hosts. Of the 5 railroads that implemented PSR, 1 has worsened its minutes of delay rate, 2 have experienced no significant changes, and 2 railroads have experienced significant improvements. Alternatively, considering on-time performance measures suggests that PSR strategies have the potential to worsen a host railroad's performance. Setting aside the CN, who began PSR prior to the earliest years of data, of the other 5 railroads, 3, the BNSF, the CP, and the CSX, showed no significant difference. However, after PSR strategies were initiated at the Union Pacific and the Norfolk Southern, the 2 railroads' on-time performance worsened noticeably. Therefore, the results of the study suggest that if implemented properly, PSR strategies will have no negative effect on a railroad's ability to host Amtrak intercity and high-speed rail passenger railway service, but that if implemented incorrectly, the host railroad can negatively affect Amtrak's train performance. Furthermore, if PSR-related double-track removals are found to have reduced capacity in a section of mainline to the point that on-time performance of passenger trains suffer significantly, restoring the second main track may alleviate the problem. A potential source of funding for such double-track restorations would be the Federal Railroad Administration's Consolidated Rail Infrastructure and Safety Improvements Program, or CRISI. However, if there are already 2 or more tracks in a section of mainline, then there are diminishing returns as additional tracks are added, and therefore building more tracks alone may not solve the on-time performance problem. For example, research has shown that a 4-track mainline section only has a capacity that is roughly 50% better than 2 tracks. In such a case, the only solution may be to raise the penalties paid by the host freight railroad for late passenger trains to ensure that passenger trains truly do receive the highest priority from the freight railroad's dispatcher, as is required by law. So, thank you. I believe we have some time for questions.
Yes, John, let me jump in, Steve here. So correct something I neglected to do at the outset. And John, excellent presentation. Let me just add that John has agreed to answer questions. So the preferred way to do that would be to hit the Q&A. So if I'm going to do that myself just to make sure everything's working as it should be. Now, as I try to do so, on my screen at least, I do not see a way to enter a question. Maybe that's because I'm a presenter and not an attendee. Actually, let me.
Stephen, this is Jim Blaze. I tried to enter questions, and the Q&A doesn't allow me to type anything in.
I see that. Yes.
So we'll have to get somebody to assist us to.
Well, in the meantime, let me, if I may, ask a question of John myself, and then we'll work on that in the meeting. So, John, out of this investigation that you've done, would you, regarding the issue of track capacity, have you encountered any kind of ranking that can be assigned to the various ways that you can get more track capacity? I'm thinking of, for example, well, the straightforward approach of just adding more track, maybe upgrading the FRA class of track, improve signaling, What else could do it? Better maintenance methods, so you're not always out there occupying the track. That's an increase in. So, and if we want to cast our net wide, we could even look at electrification, because electric locomotives accelerate and decelerate faster. But is there any ranking that says this is better than the other that you've come across?
Well, I guess having come from a track side area of the railroading world, my bias, I guess, would be, as a researcher, would be towards adding track capacity. But of course, as you're mentioning, there's very many different ways that we can get more throughput of trains. I mean, there's with the operating strategies that we're primarily looking at, and there's with, of course, which my bias is towards adding more track capacity. But there are a whole host of ways that we can look at things. And no, I did not quantify or rank the methods of adding capacity, because I think each railroad needs to pursue the path that is individually best for their situation. I think we can all agree that the Western railroads have a different sort of environment that they're operating within in strategy than the Eastern railroads, where traffic is much more dense and the distances between yards and customers is closer. So I think, if anything that was learned from this research as a primary method, is that each railroad needs to look at their own strategies and their own situation individually, and can't just try to apply a generic concept without really taking a hard look at exactly who they are, what they have as infrastructure and facilities, and find a method that is best for their individual situation. So hopefully that answered your question.
This is Jim Blaze. Let me ask a question, John. Can you hear me?
Yes, I can hear.
Okay. So while you were talking, I was thinking in terms of the freight railroads are reporting that they have had significant improvement in their overall train reliability. So, for example, they are showing periodically metrics, mostly in the quarterly presentations to investors, that the reliability of on-time performance from link to link has improved from the low 60s ratings, 60 to maybe 68% on-time performance for their freight systems, to now the low 80s to mid to upper 70s. Well, how does that translate into better on-time reliability for the Amtrak trains, which are using many of the same links? That's the first question. So I'm not sure you have had access to the railroad data for the similar lanes, and if you did, then you could do a statistical comparison to see how well the trains have been doing for the freight trains against the dispatcher sheets versus the Amtrak trains. And is Amtrak participating in this upside? That's the first question. Second question has to do with if you, Norfolk Southern just testified in one of the NEARS meeting. That's the Northeast Association of Rail Shippers. There's a MARS group in Midwest. So there's different rail freight and rail shippers groups around the US, about 4 or 5 of them. Well, Norfolk Southern testified in the NEARS group for New England that they've had an overall 10 to near 20% improvement in our overall car fleet utilization. Now, I haven't seen any testimony from shippers who own about 70% of the cars or lease them, as opposed to the pool fleet from the railroads. That signifies that those folks are reliably getting that kind of increased car utilization in loads per year or loads per month or whatever. But if Norfolk Southern's attesting that it's getting that kind of increase in utilization of what its own fleet statistics are measuring, how come they're according to what I thought you said, how come they're doing worse from Norfolk, from the Amtrak performance? Something is not translating from the PSR freight side performance to the Amtrak delivery performance. What's your comments?
Well, It's always great to have more data, and I would like to have an access to some of those points that you made. You make some very valid points. I think that, like I said, each individual railroad has their own strategies that have worked for them traditionally. And I think that as long as each of the railroads individually are also keeping first and foremost prioritization of passenger services, which they agreed to when Amtrak was created and took away that burden, as the freight railroads had described it, running passenger services that supposedly was dragging them down. They promised the federal government, if I recall rightly, that they would continue to prioritize the passenger service, even though Amtrak was running it. So I think perhaps while we're talking about better utilization of mechanical equipment and maybe railway crews, we also have to consider that better utilization also of the infrastructure, of the track corridors and such, and the dispatching of such includes better keeping of promises to our federal government, promises to our passengers that are relying on Amtrak service to get them between the cities in our rural hinterlands and not just into our major cities such as New York and Washington, D.C. I think a big thing comes down to prioritization and including that in your passenger schedules. As we're talking about utilizing equipment and train crews and people, let's talk about better service and keeping of our promises as well. Hopefully that answered some of it.
Well, no, I just wanted to post it as future research opportunity.
Oh, definitely.
My other observation is some of us network together and do these email blogs, which we don't make public, but some of my colleagues, some of whom don't want to be named, although Stephen might be one of them, we tend to wonder whether or not the precision scheduled railroading is resulting in a normalization of all trains running basically at the same speed like a conveyor belt. Which means that if Amtrak gets delayed somewhere by a significant amount of minutes, there's almost no chance they're going to recover. They're always going to be late and could conceivably get later because the conveyor belt aspect of some forms of precision scheduled railroading don't allow for mixed train higher speed versus nominal speed operation. Steve, either one of the Steves, if you're on board, what's your reaction to that? I don't want to be the only one making comments here. You have to unmute your mics if you want to talk, guys.
I'll defer to Steve Ditmeyer, but I also noticed that John has a number of other questions that I'll defer to John too as to whether he wants to take those. But good questions, Jim.
I'll respond that this all depends on the nature of the command and control system that is controlling the trains. And I'll be talking in my talk in a few minutes about how an enhanced positive train control system can indeed provide greater capacity and greater ability to make up lost time by running trains closer together and so on. So that's coming up.
Okay. Well, I see one question here that we had on the question and answer window there. So question asks, what about effects of PSR-based rationalized track capacity has on maintenance windows? Well, I did not specifically look at that question, and perhaps my other presenters can answer that. But I think rationally, if we're looking at rationalized track capacity, if there is more utilization, if more time of the day is spent running trains, well then, it would logically mean that you'd have less time available for getting those maintenance crews out of the sidings and getting them out onto the track where they need to be. Also, if we have double tracks suddenly becoming single tracks, I think prior to seeing the data, I think that we could logically say that it's going to be more difficult to get those quality long hours worth of maintenance windows. So I think there may be challenges that may arise, but on the converse to that, as we have more adherence to scheduling, well, then it's makes it easier to schedule your work crews and your maintenance trains to get out on the track and have the equipment and the crews necessary to be there when the windows are open, if they're more predictable. So that is definitely something that I would look forward to studying further, but would need cooperation from the railroads to provide the data, and we will look into that. So, so thank you. And any of the other panelists, do you have a view towards the maintenance and the maintenance windows with PSR?
I'll be talking about that in a few minutes, again, in a discussion of how scheduled railroading combined with a next generation positive train control system can, in fact, increase maintenance windows and provide for better planning of those windows and make sure that the crews have more time on track, even with more trains.
This is Jim Blaze from an economics point of view. I'm wondering that a long-term precision scheduled railroading, if in fact it does result in a levering downward of the average speed of most of the trains like a conveyor belt, I'm wondering at one point or another whether or not the financial side of the senior management of the railroad companies are going to say, well, let's lower the amount of track functional speed that we want to have. So we may see an instinctive response by the corporations long term to say, let's level this thing down to minimum FRA 4 for our mainline speeds, but we're not gonna put any high level speeds. We don't want to be running anything faster than maybe 58 to 62 miles an hour rather than 70. Those kind of things can come into play long term and have an impact on the speed classification. Now, how that's going to affect Amtrak, I'm not quite sure.
So then we have another question here in the question and answer. It says, building on Jim's question, doesn't this create a ceiling for speeds? Can't we say more about sidings and the length of sidings for freight to move aside to to let a passenger train pass? So, yes, I guess what we would say is that if we're going to be rationalizing the track and putting more single tracks with siding sections, that it would be preferable to have longer sidings, not just to park a 3-mile long train, but also to have that a little bit of movement in there to start the trains rolling so they're not leaving the turnouts at the slowest speed possible, leaving the sidings and getting back into the main. And we'd rather have them coming back in at higher speeds. So I think that when we look at going from double track sections in the main line down to mainline single track with sidings, I think if we're going to be looking at actual efficiency, I think that the gains in cost savings from not maintaining as many miles of track is going to be offset by the lost capacity. But again, this would be a great area for additional research.
Might consider putting in recovery passing sidings that are of shorter duration just to store the commuter or the Amtrak trains, allowing thus the opportunity for periodic, longer segments recovery by Amtrak. The issue with that is, though, if you're going to put a siding in there specifically for Amtrak or commuter train, that's a fully allocated cost, maybe $3.5 to $5 million per mile, depending on the siding characteristics, as opposed to one of these avoidable cost calculations that Amtrak nominally pays on. So there's some trade-offs here. Anybody else have any suggestions as to whether or not this is a good idea or a bad idea?